morning, my YouTube viewers. It's Crystal here. I wanted to make another video for you, and this is going to be on the ANOVA hypothesis test. And basically, the ANOVA hypothesis test is used whenever you have 3 or more groups of information that you need to check the means of. And so this is a little bit more, this hypothesis test is a little bit more difficult than the other hypothesis test, because instead of 2 groups of information, you're going to have 3 groups of information. So I just have this an exercise, data on exercise, where they wanted to see how much stress they had when they did yoga, how much stress they had when they did aerobics, and how much stress they had when they did weights. And so that's what we're going to work on. So the first thing that you're going to do is you're going to input the data, which is what I did. I input the data for the yoga, aerobics, and weights. And the next thing you're going to do is you're going to determine your significance level. So we set a significance level of 0.05 in this instance. Okay, and then after you set your significance level, you determine your null and your null hypothesis and your alternative hypothesis. So our null hypothesis and our alternative hypothesis is null. There's no difference between the stress levels during exercise, the 3 groups. And the alternate hypothesis is there is a difference between the stress levels of the 3 groups and their 3 exercise groups. So we've determined our null hypothesis and our alternate hypothesis. And then what we do is we calculate the means. So this is a little bit difficult, and you can see that I've got lots of calculations here on this sheet, but we calculate the means and the group means. So the mean, we're going to use the average for B, C, and D. So you're going to get your means, and then you're going to get your group means, and that's going to be the average of B12, C12, and D12. And so you have a group mean of 3. And then it says that after you calculate the means and the group means, you calculate your degrees of freedom. So you check the DOF numerator. It's going to be the columns minus 1. So it's going to be B2 to D2, and then you're going to subtract 1 from that. Then we're going to check the DOF denominator. It's going to be all of the cells, all of the elements, minus K4. So it's going to be, you're going to count B2 to D11, and then it's going to be minus K4, which is the DOF denominator, and that gives you a value of 28. Now we're going to do the DOF regression, which the DOF regression is the same as the DOF denominator, but I just wanted to, there are so many formulas that you have to know. I just wanted to keep it separate. So I spent a lot of time researching the ANOVA, and the thing about the ANOVA is they give different variables different names. So the DOF regression is the same as the DOF denominator. Then we're going to check the DOF error. The DOF error is the count of B2 to D11 minus the count of B2 to D2. So that's going to be 30 minus 3. So that's going to be 27. and then we check DOF total. It's going to be a count of B2 to D11 minus 1, which is 29. So we check mean, and then I just move that over. So mean is B13. And then I check the STD total, that standard deviation, and I just moved that over. That was B15 because we calculated the standard deviations. So the STDEV.S, S is for sample, B2 to B11, and then we did that for the 3 groups of data. And then we check STDEV.S, B4 to D14, and that's 0.08. And then I just moved that over. Now we check the SSR. It's the sum of squares regression. It's going to be B18. So we're going to check the sum of squares regression. So it's going to be count B2 to B11 times B12 minus B13 to the square root of 2. That's going to give you a 10. And then the B13 is the mean total. We do the same thing for the next column. And then we do the same thing for the next column after that. And then you have an SSR total of a sum of B17 to D17, which is 35. And here we go. We've got 35 here for SSR, sum of squares regression. We've already checked sum of square SSE, sum of squares error. This is your sum of squares error here. It's going to be the sum. It's going to be, we're going to have to check the error for every element. So the sum of squares error is B2 minus B12 to the square root of 2. And then we're going to do the same thing for the C column, and then we're going to do the same thing for the D column. And then the error, we're going to sum F2 to F11, for sum G2 to G11, and then sum H2 to H11, and then the SSE total, that's your error, sum of squares error. That's going to be F2 to H2. So you've got your 9 here. We just copied that over. And you've got your total sum of squares is 44. So here's your total sum of squares. It's going to be B17 plus F12. And then you've got C17 plus G12. And you've got D17 plus H12. And then you've got the SST sum of squares total is F18 plus F13. So this is your F18, and then this is your F13, the mean total. No, sorry, B18 plus F13. And then that just transfers over here to SST, because I wanted to keep everything in one column of data so it will be easier to calculate it. And then this mean squares treatment is K12 over K6, which is the sum of squares sum of squares regression SSR over K6, which is DOF regression, I believe, DOF regression. And that's a 17.5. Then we've got the mean squared error, which is K13 over K7. So that's going to be sum of squares error over DOF error, and that gives you 0.33333. And now we're going to check the F value. Your F value is K15 over K16. So that's going to be mean squares treatment over mean squares error. It's going to give you a value of 52.5. And then we check our p-value. The p-value is f.dis.rt, and it's going to be the f value, it's going to be the DOF numerator and the DOF denominator, which we've got up here. And I spent a lot of time researching these values, and they're not easy because basically what every website I went on, they would have like a different term for the same value. Like this mean squares treatment, that was on the statology website, and nowhere did they say mean squares treatment. And what I think is that whoever wrote that blog omitted it in error, and they haven't updated the blog to say, well, this blog is being corrected. So I was looking on the internet, and the internet said to use f.dis.rt. K18 is your F value, and then K14 is going to be your DOF denominator. No, sorry, K4 is going to be your DOF numerator, and K5 is going to be your DOF denominator. And I spent a lot of time researching this. In fact, probably I did it at work as well. And but the thing is because I need to learn Excel for work. So basically, now we check for our null hypothesis. The null hypothesis is false because you had a p-value that was less than 0.5. So that means K19, that's your p-value, is less than K2, and that's your alpha. And it's pretty obvious that the p-value was false because on row 1 you had 3 2s and 1s. Sorry, on column 1 you had 3 2s and 1s. On column 2 you had 3s and 2s. And then on column 3 you had 4s and 5s. So it's pretty obvious that it's false, but this is just proving it's false. And another thing that you can do is if you have the data analysis toolpak, you can also do this without doing all the calculations that I've done. But I wanted to do the calculations because any numpty can go into Excel and just press the little key and get the ANOVA, but you need to know how you actually came about getting the ANOVA. But if you look at the variance at the ANOVA single factor, it gives you a count, a sum, an average, and a variance. And the variance is the one thing that I didn't do because you didn't really need the variance. We were using the standard deviation. But you can see I got the count, the sum, and the average was the same. And then we come, actually, that was your summary. And then we go to the actual ANOVA. So you've got the sum of squares. Sum of squares was the same. And it says between groups and within groups. And that was between the regression and the error. So they use different terminology. And so that's what I was pointing out earlier. That's why I had such a hard time doing this, and it took me such a long time to do it, because every website you go to, they have a different term for the same thing. Then we have the degree of freedoms. Again, that's going to be the numerator is number 2, and then it says number 27 within groups. So you've got 2 regression and 27 error. And then you've got the mean squares of 17.5 and 333. And so that's going to be mean squared treatment and mean squared error. You've got your F, which is 52.5, F statistic. You've got your p-value. And the only thing that wasn't the same was the p-value, because I'm not sure what formula that they used to derive at the p-value, but I tried several different scenarios to get a p-value, and I was researching, and it came up saying the f.dis.rt, the f value and the DOF numerator and DOF denominator or what you can use, but both of the p-values, the p-value what I calculated and the p-value and what the computer calculated, were very low. So it's going to be, the null hypothesis is going to be rejected anyway. But I just wanted to show you what the computer did, just so you can see for yourself what the computer did, and you can see that my calculations were the same as what the computer's calculations are, with the exception of the p-value, and that's because I don't know what formula the computer used to derive the p-value, but both of the formulas are really low. So let's just say you want to do this on the computer, because basically, you know, a lot of people don't want to sit there and try to calculate this by hand. Now, I calculated it by hand as an exercise to do it, but a lot of people are in a hurry. Their boss is breathing down their neck. They've got to get it done. So if you want to do it with the computer, which is very understandable, you need to know how to do it. But so that's why I've done it by hand. But once you know how to do it, if you want to do it with the computer, if you've got time constraints, you've got your boss giving you a deadline and stuff like that, then you come over here to data, and you come over here to your data analysis tool. And data analysis tool is a built-in tool, and not every Excel has it. Like, I don't have that data analysis tool at work, so I wouldn't be able to do it. Like, if my boss was saying to me, I want you to calculate the p-value of this, and I want you to determine whether the null hypothesis is true or not. Well, I wouldn't be able to do it because I haven't got it at work, and it also doesn't have it when you look on Excel at online, like on OneDrive. It doesn't have it either. So I think you only get it if you pay for it, and I pay for Excel, which is one of the reasons why I'm doing all these Excel videos, because I pay for Excel. So I'm thinking, well, I'm going to do as many Excel videos as I can since I'm paying for Excel. So we have our Excel single factor, which is what we've done, and then you click OK, and then it gives you your input range, B2 to D11. It's grouped by columns. It doesn't have any labels in the first row. If you wanted to use the first row, like B1 to D11, then you would just click labels, and then that would work. And then your alpha is going to be your 0.05, and it gives you an output range of F20, which is what I've already done, because I wanted my output range to be on the same page as my work. Now, let's say if I had said B1 to D11 and I click row labels in the first row, then it would give me the actual labels. But I didn't click labels in the first row, so I didn't get that. And then you click OK, and then it will calculate it for you automatically, you know, and it's something that, you know, anybody can do. But since I've already done it, and I didn't click labels, which perhaps I should have done, the only difference If you don't collect labels, then on column 1, 2, and 3, it would have said yoga 1, aerobics 2, weights 3. So that's the only difference. So I've been talking for 20 minutes about ANOVA, and I think I've covered all of the major issues. And I've covered all of the major issues. I'll say 9. So those are your 9 steps in performing an ANOVA. So since I've covered the 9 main issues and I've talked for 20 minutes, I'm going to go ahead and conclude this video. If you like my video, please like, subscribe. Thank you so much for watching my video, and I look forward to making another video on statistics for you in the very near future.